Hello friends, in this video I am going to discuss the concept of indeterminate forms. The forms 0 by 0, infinity by infinity, 0 cross infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0 are called indeterminate forms. Since here we know limit x tending to a f of x divided by g of x is equal to limit x tending to a f of x divided by limit x tending to a g of x. Okay, taking limits in numerator and taking limit in denominator. But if we have this case when limit x tending to a f of x is 0 and as well as limit x tending to a g of x is also equal to 0, means both the limits of numerator and denominator are 0, then in that case limit x tending to a f of x by g of x reduces to the indeterminate form 0 by 0. Okay, for example, if I consider the case if f of x is equal to x square minus 1 and g of x is equal to x minus 1 with a is equal to 1, then limit x tending to a f of x divided by g of x is equal to limit x square minus 1 divided by x minus 1. Now taking limit x tending to 1 in the numerator and in the denominator as well, then we have 0 in the numerator as well as 0 in denominator also. That means it is 0 by 0 form. Okay, this is indeterminate form. Now for this limit can be solved by simplifying this numerator as applying the formula of a square minus b square. This can be written as x minus 1 into x plus 1. Now x minus 1 get cancelled out from numerator and denominator and we are left with the x plus 1 in the numerator. This is equal to limit x tending to 1 x plus 1, and on taking limit taking x to be 1 here we get 1 plus 1, that is 2. Okay, this is when limit x tending to 1, this is 0 by 0, that is indeterminate form 0 by 0. Okay. The forms 0 by 0 and infinity by infinity are regarded as the fundamental forms. These two are the fundamental forms, and all other forms 0 by 0 power 0, infinity power 0, infinity minus infinity, all these forms are solved by first converting them to one of these forms. Okay. Now we have a rule for solving these type of limits, indeterminate form limits, which is L'Hopital rule. The rule says that if f of x and phi of x be two functions such that first is they are continuous in the neighborhood of a. Neighborhood of a means we have an open interval around a. Let it be open interval a minus delta, a plus delta, where delta is any small positive number. Okay. Then first condition is that they are continuous in the neighborhood of a. Second, they are derivable in the deleted neighborhood of a. Deleted neighborhood of a means open interval a minus delta, a plus delta, where delta is positive number, and deleted neighborhood means except at the point a. Okay. And third is f of a is equal to 0 is equal to phi of a. Both f of a is 0, phi of a is 0. That is limit x tending to a, f of x is 0, and limit x tending to a, phi of a is also 0. And fourth is that phi dash x is not equal to 0 in the deleted neighborhood of a. Okay, that is for every x in open interval a minus delta, a plus delta, where delta is positive except possibly at a. If these four conditions are satisfied, then we have the result says that L'Hopital rule says that limit x tending to a f of x divided by phi of x is equal to limit x tending to a f dash x divided by phi dash x. Okay, here we have to note that we are not applying the quotient rule of differentiation. We are separately differentiating numerator and denominator. We are not applying differentiation rule of quotient rule here. Separately we are differentiating numerator and denominator. Okay, then the result says limit x tending to a f of x divided by phi of x is equal to limit x tending to a f dash x divided by phi dash x. Okay, Now here we note that it may happen that limit x tending to a, f dash x divided by phi dash x is again 0 by 0 form, indeterminate form. In this case, we can extend the L'Hopital rule as follows. If again we are getting indeterminate form, then in that case we can extend our L'Hopital rule. Limit x tending to a, f of x divided by phi of x, which was equal to limit x tending to a, f dash x by phi dash x by L'Hopital rule. It can be further written as is equal to limit x tending to a, f double dash x divided by phi double dash x. Again we are differentiating numerator and denominator, taking second derivative of numerator and denominator, but separately, not applying the quotient rule of differentiation. Okay, clear? Now therefore this rule can be generalized as follows. If f of x and phi of x vanish at x is equal to a and have their first n minus 1 derivatives all 0 at x is equal to a, while their nth derivative are finite and non-zero. If we are now generalizing this rule, if f of x and phi of x vanish at x is equal to a and have their first n minus 1 derivatives all 0 at x is equal to a, while their nth derivative are finite and non-zero, then limit x tending to a, f of x divided by phi of x is equal to limit x tending to a, f n x divided by phi n x. Nth derivative of fx and a derivative of phi x, which is equal to, on taking limit, f n a and a derivative of f at a and a derivative of phi at a, provided this limit exists finitely or infinitely. Okay, this is the L'Hopital rule. Okay, now steps which we have to follow to find the limit of indeterminate forms. There is a working rule for finding the value of limit x tending to a, f of x by phi of x, where f of a is 0 and phi of a is also 0. Okay, first step is we have to first differentiate the numerator and denominator separately. We have to differentiate numerator and denominator separately. Second is put x is equal to a and remove the word limit. Okay, on differentiating numerator and denominator separately, second step we have to follow is put x is equal to a and remove the word limit. Okay, and in the third step, if the indeterminate form 0 by 0 still persists, repeat the above process. If on differentiating once we are getting again 0 by 0 form, then we again differentiate. Again, if we are getting the 0 by 0 form, we will again differentiate both numerator and denominator. We will differentiate until we are getting the finite value, not indeterminate form. Okay, if we are free with indeterminate forms, until then we have to follow the same steps. If the indeterminate form 0 by 0 still persists, repeat the above process. Okay, clear? Now let us come to the example, some problems to understand it more clearly. Okay, now we have some examples. First we will do examples of indeterminate form 0 by 0. Okay, let us consider some problems of this form. Evaluate the following limits. First, limit x tending to 0, x ex minus log 1 plus x divided by x square. Okay, let us first evaluate this limit. Okay, now this limit x tending to 0, x ex minus log 1 plus x divided by x square. Okay, now on taking x to be 0, this will be 0, log 1 is 0 and here denominator also 0. That means we are getting 0 by 0 form. Okay. Now first we differentiate once numerator and denominator separately. Okay. First differentiating numerator. Now this is product of two functions x, ex. Now applying product rule here. Product rule of differentiation. Okay. Now this differentiating x, ex with respect to x, we get ex plus x, ex, and differentiation of this is 1 upon 1 plus x. Okay. Now same way differentiating denominator. This will be 2x. Now on taking x to be 0 here, e power 0, this is 1, this is 0, and this is 1 upon 1 plus 0. Again this is 1, this is minus 1. We are getting 1 plus 0 minus 1, that is 0, and here we are getting 2 into 0, 0. That is again we are getting 0 by 0 form. Okay. Now again we will apply the this. Again we will differentiate numerator and denominator separately, applying L'Hopital rule. Okay. Now again this is ex plus x ex, and this will be plus 1 upon 1 plus x whole square on differentiating this. Okay. And this is divided by 2, differentiating x with respect to x. This will be 2. Clear? Now on taking limit, this will be e power 0, that is 1. Here also 1. This is 0. And this is 1 upon 1 square divided by 2. And this is 1 plus 1 plus 1, 3. That is 3 by 2. This is how we have to apply L'Hopital rule. Okay, clear? Now we come to the next problem. We consider second problem. Limit x tending to 0, 10 of x, 10x minus x divided by x square 10x. Okay. On taking first solution, this is limit x tending to 0, 10x minus x square 10x. Okay. Now first we can rewrite this as 10x minus x by x square into x by 10x, dividing and multiplying by x. Okay. Now this is equal to limit x tending to 0, 10x minus x divided by x cube into limit x tending to 0, x by 10x, and we know this limit is 0. We know this. Okay. Therefore, we are left with x tending to 0, 10x minus x by x cube. Okay. Now this limit is reduced to this limit. Okay. Now we will apply our L'Hopital rule since this limit is equal to 0. Okay. We are left with this. Now on taking x to be 0 here, 10 0 is 0 minus 0 by 0. That is 0 by 0 form. Applying L'Hopital rule, we have this differentiating 10x with respect to x. We have secant square x minus 1 divided by 3x square. On taking limit as x tends to 0, this is 1 minus 1, 0, and again in the denominator I have 0. Again we are having 0 by 0 form. Okay. Then again differentiating, this is 2 secant x and secant x 10x divided by 6x. Okay. Now this is limit x tending to 0, 2 secant square x 10x by, here we have 6. Therefore, I can write as 3x. Okay. Now on taking limit, okay, on taking limit as x tends to 0, this is again 0 by 0 form. Okay. Or further I can also write this as, since we are getting 10x by x here, no need to apply L'Hopital rule since we are again having this type 10x by x. Okay. So no need to apply L'Hopital rule. I can here write as limit x tending to 0, 1 by 3 secant square x, and this is 10x by x. I can write in this form. Okay, now this is limit x tending to 0, 1 by 3 secant square x into limit x tending to 0, 10x by x. Okay, I can write this in this form. Okay, that means on taking limit, this will be 1 by 3 into 1, and this limit is also equal to 1. That means 1 by 3. Okay, here we have this. Okay, we can separate the limit in this form. Okay, then answer is 1 by 3. Okay, clear? Now we come to next problem. Now third, we have this limit x tending to a, x power a minus a power x divided by x power a minus a power a. Now we have to find this limit. Okay, right solution. Now limit x tending to a, x power a minus a power x divided by x power a minus a power a. On taking limit as x tends to a, this is a power a minus a power a 0, a power a minus a power a. Again we are having 0 by 0 indeterminate form. Okay, now for on applying L'Hopital rule, we have to differentiate numerator and denominator separately. Okay, let us first differentiate this. Here we have x power x in the this, not a, sorry, this is x power x. Okay, and this is also x power x. Sorry, question is limit x tending to a, x power a minus a power x divided by x power x minus a power a. On taking a, x tending to a, this is a power a minus a power a 0, and here also 0. Okay, question is this x power x, not x power a. Okay, now we are getting the 0 by 0 indeterminate form. We have to apply L'Hopital rule. First, we will differentiate this. Let us separately differentiate this. Okay, we have to differentiate this. Let y is equal to x power x. Taking log both sides, we get log y is equal to x log x. And on differentiating this, we get log x plus x into 1 by x. That is, this is 1 plus log x. That means y dash is y into 1 plus log x. That is, y is x power x. 1 plus log x. Okay. Hence, differentiation of x power x with respect to x is this. Okay. Now, this limit is equal to limit x tending to a. Differentiating numerator with respect to x. Okay. This is a into x, a minus 1 minus derivative of a power x is a power x log a, and derivative of this x power x is x power x 1 plus log x, and this is constant, that is 0. Okay, clear? Now on taking limit as x tending to a, here we get a into a power a minus 1 minus a power a log a divided by a power a 1 plus log a. Okay, now this is a power a 1 minus, taking a power a common, 1 minus log a, and this is a power a 1 plus log a. This will get cancelled out. Therefore, value is 1 minus log a divided by 1 plus log a. This is the limit. This is the answer on taking limit x tending to a. Okay, clear? Now we come to next problem. Next we consider this problem. Limit x tending to 0, 1 plus x power 1 by x minus e divided by x. Okay. Now we know limit x tending to 0, 1 plus x power 1 by x. This limit is 0. We know this. Okay. We can easily find this limit. We know this is equal to e. Okay. Now limit x tending to 0, 1 plus x power 1 by x minus e divided by x. On taking x to be 0, this will be e minus e, that is 0 by 0. That is 0 by 0 form. Okay. Now we will apply our L'Hopital rule. For this we have to differentiate this and differentiate this. Okay. Now let us first differentiate this separately. Let y is equal to 1 plus x divided by 1 by x. Taking log both sides, we get log y is equal to 1 by x log 1 plus x. Now differentiating with respect to x both sides, we get differentiating with respect to x. We get 1 by y dash is equal to, now this is minus 1 by x square log 1 plus x plus 1 by x into 1 by 1 plus x. Okay, that means this is equal to minus 1 by x square log 1 plus x plus 1 upon x into 1 plus x. Okay, now y dash is equal to y into, and y was this 1 plus x power 1 by x into, taking this LCM, this is x square 1 plus x. Here we get minus 1 plus x log 1 plus x, and here plus x. Okay, this is my y dash. Okay, this is my y dash. Okay, now applying L'Hopital rule to our problem, we get therefore limit x tending to e 1 plus x power 1 by x minus e divided by e is equal to limit x tending to 0. Therefore limit 1 plus x power 1 by x minus e divided by e. That was our question. Sorry, here we have x and x tends to 0. Limit as x tends to 0. This is 0 by 0 form. Now differentiating this, applying L'Hopital rule, done differentiation of 1 plus x power 1 by x is limit x tending to 0. This is 1 plus x power 1 by x into minus 1 plus x log 1 plus x divided by x square into 1 plus x, and derivative of this minus e is 0 and derivative of x is 1 on applying L'Hopital rule. Okay, now this is equal to limit x tending to 0, 1 plus x power 1 by x into limit x tending to 0, x minus 1 plus x log 1 plus x divided by x square into 1 plus x. I can write this. Okay. Now this is equal to, now we know this limit is e. This limit is e, we know, and this is equal to limit x tending to 0, x minus 1 plus x log 1 plus x divided by x square into 1 plus x. Okay. Now on taking x to be 0, here we have 0. Log 1 is 0, 0 minus 0, 0. And here we have 0 also. That means this is 0 by 0 form. Okay. Now we will apply L'Hopital rule to this limit. Okay. Now this is e into limit x tending to 0. Now differentiating numerator, derivative of x with respect to x is 1 minus derivative of this is 1 log 1 plus x minus 1 plus x divided by 1 plus x. Okay. Same way in the denominator we have this is x square plus x cube. That means derivative will be 2x plus 3x square. Okay. Now on simplifying this numerator we get x tends to 0. This will be 1 minus this is 1. 1 will get cancelled out and we are left with minus log 1 plus x divided by 2x plus 3x square. Okay. Now on taking limit as x tends to 0 here. X tends to 0. This will be log 1 which is 0 and 2 into 0 plus 3 into 0. 0 by 0 we are getting again indeterminate form. On applying L'Hopital rule again, this is divided 1 by 1 plus x, differentiating with respect to x, and in the denominator we have this is 2 plus 6x. Okay. Now taking limit as x tends to 0 here, this will be minus 1 by 1 plus 0, that is minus 1. Let us write here e into numerator is minus 1 divided by 2. This is 0. Okay. That means this is the answer, minus e by 2. Okay, clear? Now we have next problem. This is next problem, right? For what value of a does sine 2x plus a sin x divided by x cube tend to a finite limit L as x tends to 0. Okay. Second part is when a has this value, what is the value of L? What is the value of L? Okay. Means here we have to first find the value of a for which this will tend to a finite limit L as x tends to 0, and for this value of a we have to find the value of L. These are the two parts in the question. Okay. Now first we have to find the limit as x tends to 0 sine 2x plus a sin x divided by x cube. First we have to find the limit L. To find limit L, we have to find the value of a. Okay. Now limit as x tends to 0 sine 2x plus a sin x divided by x cube. On taking x to be 0, we know sine 0 is 0. This will be 0. In the numerator we have 0. In the denominator we have 0 as well. Okay. This is 0 by 0 form. Now on applying L'Hopital rule, this is limit x tends to 0, 2 cos 2x plus a cos x divided by 3x square. Okay. Now this is 2 plus a. Now on taking limit, mark this as equation number 1. Okay. Since in the denominator we have 0, but in the numerator we are not sure. Here we have 2 and here we have a 2 plus a. We have 2 plus a in the numerator, and in the denominator we have 0. But question is, for what value of a does this tend to limit finite limit L as x tends to 0? Okay, now it is given that limit x tends to 0 sine 2x plus a sine x divided by x cube tends to L. Finite limit. Okay, that means here we have here we have denominator tends to denominator of 1 tends to 0 as x tends to 0 from 1. Okay, but numerator of 1 tends to 2 plus a. Okay, now for finite limit, numerator should tends to 0 as x tends to 0. Okay, that is 2 plus a should be equal to 0. That is a is equal to minus 2. Okay, since here we see that on applying L'Hopital rule once, we are having 2 cos 2x plus a cos x divided by 3x square. On taking x tending to 0 limit, here we have 2 plus a in the numerator, but in the denominator we have 0. Okay, and question is that we have to find the value of a for which this limit we are getting a finite limit L. Okay, now if denominator tends to 0, numerator should also tends to 0. Then only we will have again 0 by 0 form. We can apply L'Hopital rule. Otherwise, if numerator is finite and denominator is 0, answer will be infinity only. Okay, therefore we are getting the value of a to be minus 2. Now we will substitute a is equal to minus 2 here, and then we will apply L'Hopital rule to find the limit L. Okay, that's the way we have to solve this question. Okay, now for this value of a, we have to find the value of L. Okay, now with this value of a, equation number 1 is equal to limit x tending to 0 2 cos 2x minus 2 cos x divided by 3x square on taking a to be minus 2 here. Okay, now on taking x to be 0, this will be 2 minus 2, 0. Denominator also 0, 0 by 0 form. Applying L'Hopital rule, differentiating numerator and denominator separately with respect to x. This will be minus 4 sine 2x plus 2 sine x divided by 6x. On taking limit extending to 0, again we are having 0 by 0 form. Again we will apply L'Hopital rule. This will be minus 8 cos 2x plus 2 cos x divided by 6. Now on taking limit as x tending to 0, we have minus 8 plus 2 divided by 6. That is minus 6 by 6 equals minus 1. Okay, this is the value of L. Okay, clear? That's it for this video. In my next video, I'm going to discuss some more problems on indeterminate forms of infinity by infinity, 1 power infinity, and other forms, indeterminate forms. Okay, if you have any queries or any suggestions, please write to me in comment box. Thank you.